start our class by explaining about oxidation reactions of aldehydes and ketones. Students, already we have discussed that aldehydes are more reactive than ketones. That means aldehydes undergoes oxidation in presence of weak oxidizing agents like Tollens reagent, filling solution, etc. So first let us study about oxidation of aldehydes in presence of Tollens reagent. Do you know what is Tollens reagent? Tollens reagent is ammoniacal silver nitrate. That means when you add silver nitrate to ammonium hydroxide, the blackish precipitate of silver oxide which is formed there, that will get dissolved in excess of ammonium hydroxide. So this ammoniacal silver nitrate is termed as Tollens reagent. When you add Tollens reagent to aldehyde, that is AgNH3 twice plus OH minus, this is Tollens reagent. Aldehyde reacts with the Tollens reagent and produces a silver mirror. You can see the formation of metallic silver on the sides of the test tube. Children, this reaction can be used as a test to identify the presence of aldehyde. Is it clear? Aldehydes on reaction with Tollens reagent produces a silver mirror on the sides of the test tube. Due to the formation of the silver mirror, it is also termed as silver mirror test. Okay, so this is the first oxidation reaction of aldehyde. On the other hand, we can see that ketones, due to its less reactive nature, are not able to undergo oxidation in presence of Tollens reagent. Second one, we can consider filling solution test. Filling solution is actually a mixture of copper sulfate and sodium hydroxide, that is the active solution of sodium hydroxide which contains sodium potassium catrate, or we can say that filling solution is a mixture of filling solution A and filling solution B, where filling solution A is copper sulfate solution and filling solution B is sodium hydroxide which contains sodium potassium catrate. So aldehyde on reaction with filling solution, you will get a red precipitate of copper oxide. So this formation of red precipitate indicates the presence of aldehyde, or we can confirm the presence of aldehyde. So these two reactions, Tollens reagent test as well as filling solution test, are considered as test for aldehyde. Okay, now ketones are not able to undergo oxidation in presence of weak oxidizing agents, but ketones undergoes oxidation in presence of strong oxidizing agents like concentrated HNO3. Let us see that process. When ketones undergoes oxidation in presence of strong oxidizing agent, you will be getting corresponding acids. Here we have to follow a rule which is termed as Popov's rule. In this particular case, we are supposed to follow a rule which is termed as Popov's rule. According to Popov's rule, this keto group will stay along with smaller alkyl group. Okay, ketones on oxidation in presence of concentrated HNO3, you will be getting corresponding acids. But the acid formation of acids will be followed on the basis of Popov's rule. So according to Popov's rule, keto group will stay along with smaller alkyl group. That means you will get a mixture of ethanoic acid and propanoic acid. Is it clear, children? So ketones undergoes oxidation only in presence of strong oxidizing agent and produces corresponding acids. And here follow Popov's rule, which states that keto groups stay along with smaller alkyl group. And the next reaction we can consider it as halophone reaction. Halophone reaction is actually a special feature of methyl ketones. That is, ketones which is associated with a methyl group are only able to give this test. In this case, first what we have to do, we have to treat NaOH plus halogen. That is, NaOH on reaction with iodine, you will get NaOH sodium hypohalite plus sodium iodide plus you will get 1. And in the next step, we can consider, suppose if it is propanol, propanol undergoes reaction with NaOI, you will get sodium salt of corresponding acid plus yellow PPT of hydrophone. Yellow PPT of hydrophone will be forming, and along with this you will get water also as the compound. Clear, children? So this test is applicable only for those ketones which is having methyl group. Is it clear? This particular test is termed as halophone reaction. So the compounds which is having methyl ketonic group is able to give this particular test. It is otherwise termed as hydrophone test. For example, suppose if you want to differentiate between ethanol and methanol, but ethanol on oxidation you will get ethanol. On oxidation produces ethanol which contains methyl ketonic group, but on the other hand methanol is on oxidation will give you methanol which is not having methyl ketonic group. So due to the presence of this methyl ketonic group on oxidation, ethanol is able to give LOPPT of hydrophone for hydrophone reaction. Is it clear? The same way we can say that if you want to differentiate between ethanol and propane 1-ol, ethanol and propane 1-ol, consider that is again ethanol on oxidation will give you ethanol. On the other hand, propane 1-ol on oxidation will give you propanol. So again we can see the presence of methyl ketone in case of ethanol. So this compound will able to give you hydrophone test. Is it clear, children? So this halophone reaction, hydrophone reaction is able to differentiate the compounds which is having methyl ketonic group or the compounds which give you this methyl ketonic group on oxidation. Is it clear? That is about the oxidation reaction of aldehydes and ketones. So now let us study about reduction reaction. This is the fourth type of chemical property, that is reduction reaction. First one, we can say that reduction in presence of metal hydrides, that is we can do the reduction in presence of hydrogen with nickel, platinum or palladium. Or we can reduce aldehydes and ketones in presence of lithium aluminium hydride or in presence of sodium borohydride. That is, if aldehydes undergoes reduction in presence of any of this reagent, whether you are using hydrogen in presence of nickel, platinum or palladium, or lithium aluminium hydride or sodium borohydride, that is aldehyde undergoes reduction and produces primary alcohol. Is it clear? Aldehydes on reduction will give you primary alcohol. On the other hand, ketones undergoes reduction under the same condition, whether it is lithium aluminium hydride or sodium borohydride, and produces secondary alcohol as the product. Is it clear? Actually, this type of reduction is termed as partial reduction. Aldehydes undergoes reduction and produces primary alcohol, but ketones on reduction will give you secondary alcohol. Children, here we have to see the difference between lithium aluminium hydride and sodium borohydride. Suppose if you just consider an aldehyde which contains a double bond, and if you use both the reagents, you can take sodium borohydride in one case and lithium aluminium hydride in the other case. When you use lithium aluminium hydride as the reducing agent, you can see that the product will be this, even the double bonded carbon undergoes reduction. Is it clear? You will be getting 3-phenyl propane 1-ol as the product. On the other hand, when the reduction takes place in presence of sodium borohydride, you will get only, that is, only CHO group undergoes reduction to CH2OH. That means sodium borohydride is unable to reduce this double bonded carbon. Is it clear, children? So whenever aldehydes or ketones undergoes reduction in presence of lithium aluminium hydride or sodium borohydride, you will be getting, in case of aldehyde, you will get primary alcohols, but in case of ketones, you will be getting secondary alcohol. Okay. Second type of reduction we can consider it as Mervin-Pondorf-Verley reduction. Mervin-Pondorf-Verley reduction. Okay, so in this case, what happens? Suppose if you just consider ketone undergoes reduction with isopropyl alcohol in presence of aluminium isopropoxide. The reaction takes place in presence of aluminium isopropoxide. Okay, you will be getting, that is secondary alcohol. The product will be secondary alcohol and acetone as the product. Is it clear, children? So whenever that is ketone undergoes reduction ketones undergoes reduction with second isopropyl alcohol in presence of aluminium isopropoxide and produces secondary alcohol as the product. This particular reaction is termed as Mervin-Pondorf-Verley reduction. Okay, next one we can consider formation of pinacol. Formation of pinacol. In this case, if you consider ketones, that is 2 molecules of ketone undergoes reduction in presence of magnesium followed by reaction with water. Okay, when it reacts with magnesium, you will get an addition product. When it continuously reacts with water, and you will be getting pinacol as the product. Is it clear, children? Here we can say that is when ketone undergoes reaction with magnesium and water, it results in the formation of pinacol as the product. Next one, let us consider Clemencian's reduction. That is a very important reaction. You can see that almost in all years in the board, this question used to be asked about Clemencian's reduction. Clemencian's reduction means the reduction of aldehydes which takes place in presence of zinc amalgam and HCl. Clemencian's reduction, it takes place in presence of zinc amalgam and concentrated HCl. That is aldehyde undergoes reduction in presence of zinc amalgam and concentrated HCl and results in the formation of alkane. So it is complete reduction. Okay, aldehyde undergoes reduction in presence of zinc amalgam and concentrated HCl and produces alkane as the product. And the next one we can consider Wolff-Kishner reaction. Wolff-Kishner reaction. In this case, again aldehyde undergoes reduction in presence of hydrazine and a base. It produces alkane as the product. Okay, aldehyde undergoes reduction with hydrazine and KOH and produces alkane as the product. Last reduction we can consider with HI and red phosphorus. With HI and red phosphorus. That is aldehyde undergoes reduction in presence of HI and red phosphorus. Again you will get alkane as the product. Is it clear? That is about the reduction reactions of aldehydes and ketones. Now we have to study about some special reactions that we will do in next class. Thank you, children.